Okay, that means this is our last session. It's the final review session. And I will try to go through the entire material, but of course I will narrow the stuff because we can't really squeeze 12 weeks in 1 hour. Okay? That means first of all, we can see the information below. The test will be available from Thursday, which is August 2nd, until Wednesday next week, August 8th. That means during this time, you can book your appointment at Examity, which most of you, almost everybody did. I'm happy with this. And then you will take the test during that time. Also, the practice test is actually open right now. That means you can even try to take it now, if you're ready. And then also the due time date is the same, Wednesday, August 8th. Okay, before I start, of course, I really want you to practice a lot. We have a few final days, and you probably know what to do. What's the best way? The best way is to use the sample test as a real final exam review tool. That means you can print the sample test. I think we have 4 or 5 of them. That means print one of them. Do not check the solution. Okay? Try to maybe time yourself. That means you will have 120 minutes to take your test. That means the sample test you can print, you can try to take it without any notes, any electronics, any books, no breaks, okay? And then try to use only 120 minutes, and then you can check the results against the solution posted on Canvas. And I think if you will grade for yourself, this will be your real readiness, will be the real indication of the readiness for the actual test. Because if you will treat this sample test as a real test, then you will see how difficult they are. Okay? But if you're doing well with the sample tests, all of them, then I think you're ready and you will do the same thing in the actual test. Okay, I see some question. Would you also recommend we also do the old sample test as well as just... Josh, you're probably asking for the midterm 1 and midterm 2. I think, yes, I think you can try. It's also good type of the exam type question. But, I mean, any tests are good. I will, of course, if the time allows, yes, I will also try to go through exam 1 and exam 2 sample test. But first of all, let's focus on the final sample test, because the final sample test will cover the new material also. But if you would like to practice the material for the first and the second test, yes, I will also recommend to take them. Okay? That means but again, please remember, of course, it's the message to everyone, and I think I repeat this multiple times, and I still have students that they didn't hear this. Because some of the students, they don't really watch the session. You don't have to attend. Of course, I'm so happy that I have the live attendees. That's really nice. And that's the reason that I'm trying to change the hours of the session. Because some kids can attend in the morning, some kids that can attend in the evening. But even if this doesn't work for you, make sure that you're watching the session. Okay, always is really important. We do have students, unfortunately, in this class that they never watch the session. And the most important information is from the instructor. I'm doing of course, I'm putting everything on Canvas for you, but the message is really important. Okay, that means always watch the session. Whatever I'm doing, it's really important. Okay, that means I think we can start. If you have some technical questions, I can ask. If not, I can start the session. But please remember, practice a lot, okay? And treat the sample test as an actual test. Okay? Then you will see how difficult it is, because it's not true that you will tell me later, oh, the sample tests were extremely easy and the actual tests were not. Of course, during the actual test, you have no breaks, you don't You don't have notes, you don't have electronics, it's just you and the test. That means try to take the same way, try to treat the same way the sample test. And I'm guarantee that you will master your skills and you will be successful on your final. Okay. One thing I will update, because the last homework assignment I think is due Friday or Saturday. That means as soon as the due date will pass for the homework assignment, I will update the entire grade book on Canvas. Okay, and then you will see all of your numbers, and of course the final exam score will be also added as soon as you take it. Okay, that's me. Let's do it. What I will do, probably you saw my email and I mentioned that the distribution of the question will be like 30% of the material from the first test, another 30% from the second test, and 40% of the new stuff. That means a little bit more from the new stuff, which the stuff I didn't test it because that was after the second midterm. And what I will do, I will start the review with chapter 5 and 6. Okay, that's when we will kind of go backwards because that's the newest stuff, and hopefully we can reach chapter 1. That means chapter 5 and 4, that was integration and application of integrals. Okay, that means let's see what I have as a first question, or theoretically the last one, chapter 5. That means I will solve the question for you, and again, you may solve them again after the session or during your review, and please do not miss any question, okay? Okay, let's start. I will switch off the video, which I like that you actually seeing me because it's just better connection, but I will switch the video for the better internet connection. Okay, I'm still there. That means let's start. If you have any question, please ask anytime and I will stop and answer your question. Okay, find the integral expression which represents the volume of the solid of the revolution obtained by rotating the region about the y-axis bounded by two curves. Okay, and let's see what we have. We do have parabola, up and down, and we have just the straight line y equals to x. That means we have to find first of all the region, and then we will indicate the rotation and the method for that we're gonna apply to get the volume. And you can probably see we have to just find the integral expression. We will not evaluate. I know that I think 1 or 2 homework assignments I did ask you to complete the question fully, like get the final numerical value, but this is of course excellent for the practice at home, but not on the test. On the test, we just need an integral. That means, let's see. We need points of the intersection. Or maybe we can draw the function. Let's look at the parabola. I can factor out x, maybe negative x. And I can see that parabola is 0 if x is 0 or x is 6, right? Because we just need 2 zeros, 2 points. We know that parabola is open down because of the leading coefficient. That means I can, a little bit skew, I can draw this parabola. Okay, 0 and 6, done. Now I do have a line y equals to x. Oh, I think like that. That means I do have a point of intersection. Oh, I don't know what it is. That's supposed to be a question mark. Looks like 2, but it's, I don't know if it's 2. And we do have that part bounded by these 2 curves. And the rotation is done by the y-axis. Okay. Actually, let's find this point of intersection, okay? Let's find point of intersection. Negative x squared plus 6x must be equal to x, both of the lines. Okay, that's what we have. Let's change the sign. Positive x squared minus 5x equals to 0. I can factor out x, and I have 0 and 5. That means 0, and this is actually 5. Okay, that means we do have the point. Okay, now we need the volume. And we can see one thing. The rotation is going to be done by, like, about the y-axis. If I would like to use the washer method, I have to integrate in terms of y, right? Because the rotation is in terms of y. And I have to take this equation, okay, the first equation, and I have to solve this equation for x to have the y expression. Okay? And we can see it's not easy. It's like x squared x, how can I factor out? How can I isolate only x on this side? And that means it's not the easy way. That's mean what we can do. We can actually use the cylindrical shell method. Then, if the rotation is done about the y-axis, we will integrate with the opposite. We will integrate with respect to x. That means this is the formula. Integral from a to b 2 pi r h and dx. R is the radius of the cylindrical shell, and h is the height. And my cylindrical shell will be, I can take maybe one of this part, and this will be the height, and the distance, this is of course x. The distance from the rotation, because we will have, I don't want to draw the entire shape, but we will have the cylindrical shell on the, I mean this part on the other side. I'm just trying to draw the 3D. No, I don't know if it looks good, because the entire yellow part will be on the other side. That means each of this yellow, actually, of this yellow lines will create a shell, and I can like rectangle, which I will rotate and create a shell. That we can see the distance from the core, from the center, yeah, it's the radius, and the height, of course, it's the height. I mean the distance between these two curves. Okay, and everything in terms of x. That means height, yeah, is just the vertical distance between two curves, as I said. That means this is the first curve, let's say, and this is the second one. The first one is defined as a negative x squared plus 6x, and the second is just x. That means negative x squared plus 6x minus x. Because in order to get the length of a vertical line, we have to get the top value minus the bottom. Top minus the bottom. Okay, that means that's what I will put. Negative x squared 6x minus x with respect to x. 2 pi I can put outside. And now I need radius. And radius is just because the rotation is just about the y-axis. That means the distance from y along the x is just simply x. If we shift, if we have different lines that the x-axis or y-axis, then we do have like some addition or subtraction. Okay, and the limits of integration is from a to b. That means in this case, we can see, because I'm slicing my yellow part, which starts at 0 and ends at 5, from 0 to 5. And that's it. That's what I like. Actually, let me correct this. That's what I like to see. We have 2 pi, radius, and height. And then we can see 6x minus x, probably you can put 5x, or please do not be surprised if you will actually see this, because that's the real settings. Okay, that's h, and I can actually write the radius. Okay, that was cylindrical shell method. Oh, hang on, we have a question, because I have to look at different screen for my chat box. Josh is asking, why is the radius x? Because it's just the distance. Can you see it's just the distance? X could be any number between 0. Like let's say I draw just one shell, and let's say this is 1. That means the distance from y-axis to that point is 1. Is corresponds to the x values. If this will be 2, it's 2, 3, 4, 5, any value between 0 and 5. That means since it's along the x-axis, it's just x. Make sense, yeah? Okay. Like any horizontal lines will correspond to x. Okay, let's keep moving, but yes, any question, I'm trying to watch the chat box. Okay, question number 2. We have to find a region which is bounded by cube root of x and x squared. And then set up an integral that will represent the volume of the solid generated by revolving that region around the line x equals to 2. That's me. Now let's see, we will have extra exercise. First of all, our curves. That means what we need. X equals to 2 is on the other side. I'm just trying to plan this. That means x squared looks like that, and cube root of x looks like that. And we can see that's the point of intersection, which of course is 1. That means I'm going to remove that part and this part. This is x squared. This is cube root of x. We know the graphs because that's the basic graphs. And that's the region. Okay. In this case, you may probably realize that doesn't really matter what method we will use. Because looking at the equation, y equals to cube root of x, I have solution of y. I can definitely solve this equation for x and have the expression in terms of y. I can also solve this equation for x and have y. That means either way will work. But yeah, let's see what method. We can even set up both of them. Okay, and what I need my line of rotation, which is actually this line 2. X equals to 2 is a vertical line. That means since it's the vertical line, everything has to like correspond to the y. It's because it's the same like the y-axis. It's just shifted, okay? Like 2 units to the right. And if I will use the washer method, which I think I can use the washer method, I have to integrate with respect to y, because the rotation is done almost like with respect to y, it's just shifted. If we will choose the cylindrical shell, then the rotation is theoretically with respect to y, then I have to integrate with respect to x. But let's maybe use the washer method. A cylindrical shell doesn't matter. Okay, that means if I will rotate this, I just wanted to make longer, because what I will do, I will have 1, 2, I'm just trying to be symmetric. I will have the same region. I hope this is my mirror image. That means I will have the same region on this side, and of course this will be like the solid. I don't want to mess up my graph with my 3D. But the washer method will give me the inner radius, this one, and the outer radius, this one. Let's make bigger, okay? Because you can probably imagine we will cut with the perpendicular, with the plane perpendicular to the y-axis, and that will be the washer. That means if I will use the washer method, the volume will be, I have to integrate just the cross-sectional area, which is the washer. Pi r squared minus pi r squared with respect to y. Let's put from A to B for now, okay? That's we can see. And now we have to find the bigger radius and the smaller radius with respect to y. And what we're doing, we slicing actually, I will use this one color, maybe this one. We actually slicing the y-axis from 0, and this is of course 1. That means we might ignore the yellow part, because the yellow will be good for the cylindrical shell. Okay, that means now let's try to find out the bigger radius and the smaller radius. and the limits of integration, since I'm showing you that we slicing the y-axis from 0 to 1. That means this will be 0 and 1. That's the y values. Yes, we can see y values. Okay, let's see radius. That means this is again x-axis, I mean the x value, which is touching that curve, and this is like another x. They are a little bit different, right? Because they are x values. I can maybe even put 1 and 2. They are the x values, but they touching different functions. That means they are defined differently. Okay, that means radius, the inner one, the small one. What we have, we do have a horizontal distance. In order to get the length of a horizontal distance, you have to subtract the right value minus the left one. Right minus left. Yes, we can see 2 minus x, x sub 2. But now I need everything in terms of y. That means we can see that the inner radius is touching parabola. And let's solve parabola for x, because I need, which will be square root of y. Okay, that means this is the formula for the small radius, because I need the x value, but with the connection with that curve. Okay, now the same thing for the big radius. The right value minus the left one, 2 minus x. And that x is touching cube root of x. If I will solve cube root of x for x, I will have y cube. Excellent. Okay. That means that's almost everything. The volume is defined, I can factor out pi as an integral from 0 to 1, big radius squared minus small radius with respect to y. Big one is 2 minus y cubed, 2 minus square root of y. And I like to put this brackets. Okay, that's the washer method. Okay, let's leave it. That's we did one cylindrical shell, one washer. I think it's enough. Let's see, I will skip this one, or maybe not, because I always skip a little bit of questions because they are similar concept, but I always add the solution at the end. Actually, let's maybe do it because it's different. Let's set up. That means this will be our last question for, no, let's skip it. Because I do, yes, I have similar question, but we do have multiple choice option, maybe will be helpful for you. Okay, set up, but do not evaluate an integral for the volume of the solid generated by rotating the region bounded by 3x minus x squared, that's parabola, and the x-axis. The x-axis, we know, is just a horizontal line. And the rotation is done with again, the vertical line, x equals to -1. That's me. Let's see, maybe you even know the final answer. But what you can notice, you can probably notice that having this parabola, I will be not able to solve this equation for x, which means I cannot get the expression in terms of y, which probably I have to integrate with respect to x, since I have the formula. Okay, but let's see the situation. That means I need this parabola, the rotation, let's see this. This parabola, if I factor out 3, I mean x, I have 0 and 3, and leading coefficient, a little bit, 0 and 3. And the x-axis, of course, we know where is the x-axis. That means this is my region. And the rotation is done with respect to the line x equals to -1. That we have to, I will not mess up my graph, but you have to picture this yellow part as like a mirror image on the other side of the blue line. Okay, And we can see the rotation is done almost, like the rotation is done with respect to the vertical line, like the y-axis. That means theoretically, if I use the washer method, I have to integrate with respect to y, but I can't do this. We will integrate with respect to x using the cylindrical shell. That's mean one more time, this is my shell. That's the height, and this is radius. Okay? And again, cylindrical shell is volume to pi radius height with respect to x. And the yellow part is my slicing from 0 to 3. Okay, we do have a question. Erika is asking, if this wasn't a multiple choice, how would you know that the integral is? Oh, can you see my yellow part? Like, can you see I am kind of like shading this region, but I always use this as a, how can I say, like making a sub-intervals. I always call slicing, because slicing and adding the stuff together means integration. And you can probably see my yellow part starts from 0 and ends at 3. That's my limits of integration. Makes sense? Because the integration, the symbol of integration is S, is the summation. We adding. I don't want to draw like all of these. I don't want to draw all of these. I prefer to keep yellow to all of these shells, but we know that this is the picture that I draw, the H and the R is only one shell, but we're creating more, like infinitely many shells, starting from 0 to 3. Does make sense? Yes, yeah, okay. Oh, no, hang on, you're asking, where would we get, what numbers? You asking 0 and 3? The area between the parabolas and the x-axis is all between, yeah, it is between 0 and 3, because we know how to draw the parabola. That's actually the numbers, 0 and 3. Yeah, that's from parabolas. Yes, okay, that means that's the parabolas, and we can see that's the region. That means since the region is between 0 and 3, the integration is from 0 to 3, because we're applying this. Okay, that means let's just set up, maybe actually you know the final answer, 2 pi outside from 0 to 3, and now I need radius. That means radius, it's again a vertical distance. This is just x. That means x minus -1. The right number minus the left one, which is x plus 1. Okay, that's the radius. And the height, it's the top dot, the top value minus the bottom one, which is just the function 3x minus x squared and minus 0, which of course it's silly to put the 0. Okay, that's h. Okay, that means that's the final answer, which I hope we can find D. It's a D option. Okay, that means that's how we can get the limits of integration, which actually, I mean, all of them are from 0 to 3, but looking at the options, we can always take the advantage, right? And we can, but of course, I will prefer if you will not have the option and you will figure out on your own. Okay, let's look at this one, which we can probably skip this one. I think you can figure out. I will give you the final answer later. That's the same thing. Okay, areas, because that was section 5.1. Yes, we're getting backwards. That means let's just try to find an integral that represents the area, which is bounded by two curves. Root x, everybody knows the root x. Okay, nice and easy. linear function, 3/2 minus 1/2 x, which means the slope is negative, okay? That means the line will go down, and the y-intercept is 3/2. That means I'm guessing this line like that. 3/2, and it would be nice to find this, or maybe we can even find the point of intersection. Okay, we will try to find this one in a minute, but that's definitely the line. And actually, y-axis, interesting. Can you see? It's actually this region. That's been my, and again, can you see my lines, my slicing? It starts from 0 and end up, oh no, I don't know if this is 2, question mark. My question mark are not. That means the limits of integration will be from 0 up to that point. Yeah, we can try to figure out the point of the intersection, and we know that the area bounded by 2 curves is simply the top curve minus the bottom. That means you can see the top is the line. Can you see this is, actually, probably looks like answer D, because line is defined like that, minus the bottom one, which is the square root of x. That means this must be 1, but what I will do, point of intersection means square root of x must be the same like 3/2 minus 1/2 of x. Okay, that means this equation doesn't look nice and easy because it's like the square root. We have to probably square both sides. But what you can try, we do have, can you see we do have a little bit of options, that we may take the advantage of this, or we can just try to figure out, like by trial and errors, we can try to substitute. That means if I will substitute instead of x1, square root of 1 is 1. 3/2 minus 1/2 is 1. That means x equals to 1. Because if we will spend time solving this, will be, I mean, probably it's not bad. We can still get the quadratic equation and get some values, but that's the easiest way. And especially we have, if you will substitute 3, because that's another option, this will not work. Square root of 3 is not this. And if we will put 3/2, we will also not get the left and the right hand side the same. That means this is 1. Probably the coefficients, like I mean the numbers in the line are setting this way to get the nice intersection. Okay, that means that's easy. Integral from 0 to 1, the top function minus the bottom one. Don't even have to repeat this. Okay. Okay, let's look at another area. Okay, let's try. Actually, let's try, because this one, can you see, is the parabola the other way. That's when we have function x with respect to y. I did solve this last week, but let's do it. That's when we have 2 functions. This is just the line, negative x plus 6. But this one is the parabola the other way. It's y squared plus 4, which means y squared will be open up. I can't say up, I have to say open in the positive direction and shifted 4 units to the right. That means this is just like that, 4, and that will be 4. X equals to y squared plus 4. And the line is actually, how can I draw the line? 6 is the y-intercept, and 6 is also a negative. I think like a little bit. Let's do this, 6 and 6. That means what we have. We do have points of intersection. That means this is the region. And since the first function is with respect to y, do you remember we also have the option to set up an integral with respect to y, which I will subtract the right curve minus the left one. But what I need my points of intersection. That means I need these points. Question mark, question mark. Because again, you can see my slicing. I'm doing from the bottom blue dot up to the top one. That means that's my limits of integration, and the right curve with respect to y, which is, I can solve this for x, and we will have 6 minus y. That means this curve, the right one, is 6 minus y, and the left one is ready, y squared plus 4. Or negative y plus 6, I can write this way. That we can see. That's not good, that's not good. That's square, that's not good. Okay, I did eliminate. B or E is the good answer. Because we do have negative y plus 6, negative y plus 6, minus a parabola, y squared plus 4, y squared plus 4. But now the limits of integration. Yeah, let's see. Points of interception. What I need my right curve, which, or left one, doesn't matter, y squared plus 4 equals to negative y plus 6. Y squared plus y minus 2 equals to 0, the quadratic equation. Let's factor out y 1 and 2 plus or minus 1 and negative 2. Negative 2 and 1. Excellent. That means answer B is the correct answer. That's not good. Okay? We can see how nice. This is the other way. Instead of the top minus bottom, it is right minus left. Okay, I think chapter 5 is good. Let's move on. Area, I will leave it this one, I will leave this one. But one more comment, even if I did skip the question, please check, because I will put the slides, the PDF file of the slides, please check the solution, okay? Or please practice. It's the same concept, just different functions. Okay, now chapter 4. Chapter 4 was just about the integration, and we have to know how to integrate. Okay? You will probably see lots of integrals. Okay, evaluate the following integral. And the integral is from negative 2 to 2, and it's the absolute value of 2x minus 1. That means as soon as we see the absolute value of the linear function, I think we can draw a function and just get the integral through the net area. Let's draw a function, 2x minus 1, absolute value of it. What we need the 0, I mean the x-intercept, which will be 1/2. Okay, that means function must be, the v must be attached at the 0, which the 0 of this equation is 1/2. The x-intercept is 1/2. Okay, and the limits of integration, oh, my graph is a little bit, hold on, because I just like to be a little bit, okay, from negative 2 to 2, let's say this way. Okay, I need that point, and I think this is the same, at the same level. Even if not, we can find the values. Okay, that means the region that we're looking for, the net area will be the area of that triangle and this one. If we substitute negative 2, function is still the same, and the value at negative 2, it's negative 4 minus 1, and it's actually 5. That means this number it's 5. But what about 2? Oh, that means that's different. Because if I substitute 2, I have 4 minus 1, 3. That means my graph, it's a little bit different. We don't need this part. Okay, because the value at 2, am I right, is 3. The value at negative 2 is 5. Okay, that means the triangle on the right-hand side is just smaller. Okay, now we need the area of this one and the area of this one. And that will be the integral. That means that's the easiest way to deal with the absolute value of the linear function. Okay, the first one is 1/2 times base times height. The second one, it's 1/2 times base times height. Okay, who can tell me, because actually I'm not asking you a question. Can you tell me the base of the first triangle? What's how many units we have between negative 2 and 1/2? 2.5, thank you. 3/2. And what about the height? The blue line on the left? What about the height of the first triangle? It's 5, yes, that's what I was looking for. Okay, now how many units we have between 1/2 and 2? What's the base of the second triangle? Yeah, how many units between 1/2 and 2? Oh, no one know the answer? Come on, how many units we have between 1/2 and 2? It's 3/2, thank you. Now, oh no, it is. Am I getting crazy? It is the first one. Oh, yes, because it's 2.5. Thank you. It's 2.5. 5/2. Thank you, Zach, for this one is 3/2. Yes, this one is 2.5. 5/2. This one is 3/2. And okay, and what about the height of the second triangle? It's 3. Okay, that means let's get 25/4 and 9/4. 34/4. Okay, I hope I did my math correctly, my arithmetic. Okay, yeah, but we can see that's what I wanted to tell you, that if we have an absolute value of the linear function, that's the easiest way. Okay, don't miss this one. Okay, and just a little bit of integration. Who can tell me the integral of sine of x? That's just the direct antiderivative. Correct, negative cosine of x. Negative cosine of x from 0 to pi. Negative cosine at pi minus negative cosine at 0. Okay, cosine at pi. Cosine at pi is -1, and with this negative will be +1. And what about cosine at 0? Cosine at 0 is 1. Oh, what I can do? Can I just do like that? Yeah, we have to be careful because it's minus -1 plus 1. Okay, 2. Just the simple. Let me just ask you, but what's the integral of cosine of x? The integral of cosine is just sine of x. Okay, good. Okay, now, what's the integral of secant? I have just a red line, I can't. Secant square of x. Who remembers that integral? Integral of secant square of x? Who? Oh, no, we have to know. Okay, I know you brave enough to attend the live session. It's tangent, right? Because derivative of tangent is secant square of x. Oh, I can't write. Okay, I can write, oh, now I can write tangent of x. And a little bit of unit circle. tangent at 45 minus tangent at 0. Oh, I can use this. Tangent at 45, can you tell me? It's just 1. Tangent at 0, of course, is, I'm waiting, 0, 0. Thank you. I was waiting for you to tell me. Okay, 0, which is the final answer, 1. Okay. We can see how nice and easy question you might have. Okay. Okay. Now, integral from 1 to 2 root x plus 1 over root x. That means probably we can, since we have only one item on the top, we can just split this one and this way and this way. From 1 to 2, square root of x over square root of x, 1 over square root of x. 1 plus x to the negative half. Okay. From 1 to 2. Probably we can use the u substitution, but we don't have to, especially if we have one function in the denominator. Okay, integral of 1 is x. Integral of x to the negative 1/2. Hopefully you agree, or maybe I'm wrong. Because the integral of x to the negative 1/2, I wanted to change the color, will be x on, oh no, x to the power of 1/2 over 1/2, which is 2 root x. Okay. Well, I know what we can do. Let's change the limit for 4. I think that's supposed to be 4. Then we have nice square roots. Okay. 4 plus 2 square root of 4, 1 plus 2 square root of 1. 4 plus 4 minus 1 minus 2. I think it's 4. Okay. Yeah, that means that's the fundamental theorem of calculus part 2. Like we know how to integrate using the upper and the lower limit. Okay, but that's my point. Oh, hang on, somebody is, did I make the mistake? Oh, where is my mistake? Oh, 1. 8 minus 3, thank you, Kristen. It's actually 5, yeah? Okay, good, yes, good eyes. Okay, let's look at the next integral. Oh, actually, it's the multiple choice, but it's the same thing. Okay, that's when you have to divide this term by x, this one by x, and this one by x. Okay, that means, and it's the same idea. That means I can leave it this one for you. You can check later the answer. And let's solve this one. Integral of sine of x times cosine to the power of 9 of x dx. What do you think? How we can solve this one? Do you think you can tell me? No, like what? The u substitution, right? That means what shall I choose for? What formula shall I pick for u? Do you remember the? Do you remember like the method is cosine? Because we can see sine of x, and I see something to the power of 9. That means that something, of course, is cosine of x, and that's my inner function. Derivative of u, it's du. Derivative of cosine is negative sine of x dx. I can put just negative, and sine of x dx will be negative du. I can rewrite this. Okay, and cosine of x was u to the power of 9, and this part is negative, which actually I can put that negative in front, negative du, u to the power of 10 over 10, negative, and we can put back cosine. of x to the power of 10 over 10, of course negative. Okay, that's the nice u substitution. Okay, let's see next one. What about this one? We have an integral of 5x cubed times square root of x squared plus 1. It's definitely the u substitution, okay? But what do you think? What shall I choose for you? What substitution shall I pick? Yeah, it's always this, I mean, it almost always works. When we see product of two functions or the quotient, yes, we have to look at the more complex and pick the inner function, which is perfect, x squared plus 1. And du is 2x dx, and I don't really see 2, that means I will divide. But now let's see, we do have a few steps. I will put 5 outside. X cubed, I will change for x squared times x. That's mean, can you see what I did? I did put x cubed like in two places, because x squared times x is still x cubed. Because we can see in my u substitution, I end up with x dx. That means x dx, it's 1/2 du. This was square root of u. That was 5. But now I have a little bit of problem, because as soon as everything is in terms of u, I can't just put x squared. That means I have to rewrite x squared in terms of u. And can you see the equation that will actually give me the expression for, it's u minus 1, right? I will take this equation and I will solve for x squared. Just u minus 1. Excellent. U minus 1. I will distribute u and u squared, u and square root of u, and u square root of u and 1. 1/2 I will put in front. That's mean u times root u, 1 times root u. Because now I can multiply, it's the same type of function. U to the power of 3/2, u to the power of 1/2. And now we can integrate, no problem. U to the power of 5/2 over 5/2, u to the power of 3/2 over 3/2. But just instead of u, we have to substitute x squared plus 1. Okay, I don't have enough room, that means I will remove that u. And I will put x squared plus 1. Okay, that's the way to do the u substitution in this case and the extra blue step. Okay, let's see what else. Okay, that means let's just maybe, actually, let's look at this integral. Again, a definite integral from 1/2 to 1, cosine of x to the -2 over x cubed. That means, what do you think? What will be the good substitution? Because it's definitely for the good for the u substitution. Well, again, the inner function, right? That means the inner function is x to the -2. Derivative is -2 x to the -3 dx. I can divide by -2 and I can rewrite x to the -3 as a 1 over x cubed. And this is this. Right? That means this will be -1/2 du. And let's see what we have. Oh, cosine of u. Okay, that we do have actually -1/2 du and just cosine of u, because x to the -2 was u. Okay, that we can probably nicely integrate. I have -1/2 integral of cosine of u is just sine of u. The only thing is, we do have a limit of integration, and you probably remember applying a u substitution with a definite integral. We have to find a new limits of integration. That's new limits. If x was 1/2, what will be the corresponding u value? And if x is 1, what's the corresponding u value? Okay, if x is 1/2, we are substituting here. That means u is x to the -2, 1/2 to -2. And I'm just using this. That means what is 1/2 to the -2? I think it's 4. Okay, and 1 to the -2 is just 1. That means it's from 4 to 1. Okay, that means actually 4 is not a helpful number. Actually, we don't even have, hang on, how can I do it? -1/2 sine of 1 minus sine of 4. Okay, I can actually leave it. I wanted to, we can just leave it because the limits of integration are not really helpful. We don't really know what is sine of 1. We don't really know what is sine of 4 because that's not even the radians values. I mean, they are the radians. We don't even know the degree, but we can just leave it because we know only the special values. Sine at pi/3, pi/4, pi/6, and of course the multiple of 90. Okay, that means let's just leave it. Okay, that's what was my point. My point, of course, is again new substitution and new limits of integration. Please do not substitute the 1/2 and 1. Okay, now let's see what I have. Okay, let's maybe integrate. It's still the u substitution, but let's try to get the answer. Okay, who can tell me the u substitution? I mean, what u substitution shall I pick? Oh, no, but no one? I know that you can definitely tell me. Just tell me the inner function because we see two functions. We see 3x and we see square root. Yes, x plus 1, thank you. And du is just dx. Ah, really nice because it's the same thing. That means what we have? We have, oh, okay, we have square root of u, dx is du, but what about 3 times x? I can't put x. I really have to put something with respect to u. That's me looking at the substitution. What is x equal to? U minus 1, thank you. That means from this, x is u minus 1. U minus 1. And let's simplify. I will put 3 outside. U minus 1 over square root of u. U over root u. Okay, and u to the power of 1/2, u to the power to the power of -1/2. And we can integrate. But now, can you tell me the new limits of integration? Like instead of 0, what will be the corresponding u value? It's gonna be 1, and instead of 3, it's gonna be 4 because it's just x from 1 to 4. Very good. From 1 to 4. I can maybe put here. Okay, let's try. U to the 1/2 will be u to the 3/2 over 3/2. U to the 1/2 over 1/2. From 1 to 4. Okay, I can flip a fraction and I can put 4 to the, now let me, too messy. Let's rewrite one more time. 2/3, and this is square root of u cubed. 2 square root of u. A little bit better. And now let's substitute upper and the lower limit. Yeah, you probably know the answer. I hope square root of 4 cubed minus square root of 4, and then 2/3 square root of 1 minus 2 square root of 1. Okay, let's figure out the values. Square root of 4, of course, is 2. 2 cubed is 8. 8 times 2 is 16/3. And this one is 4. This one is just 2/3 minus 2. Okay. That means we do have 16/3 minus 2/3, 14/3, minus 4 plus 2, minus 2. Oh, what's the answer? 14 minus 6, 8/3, which that's the only answer with the denominator 3. Okay, that's what is important on this slide. Again, the blue part, we can see the blue part. It's the extra step to get rid of the x, to have everything in terms of u, and the new limits of integration. I didn't write the computation, but I know that you are okay. We're just adding 1. Okay, let's see what else, because I don't want to solve lots of stuff. I mean, again, probably I'm repeating for them multiple times. All of the questions here are quite helpful, okay? Okay, we will not solve this one because it's similar idea, but can you just tell me what will be the good u substitution? Just tell me this, and then I will give you the final answer. Yeah, just the inner function. Okay, that's okay, probably that. Yes, thank you. Thank you, Kristen. That's the, and then you can figure out the rest. This will be cancelled out. You can definitely get just the u to the power of -9. And of course, some different limits and maybe possibly some negative number in front of the integral. Yes, actually x, I mean x to the 1/2, not the u. Okay. Okay, what u substitution we can get here? Who can tell me? It's x times secant square of x squared. That's mean again the inner function x squared, and we will cancel out on this one. We will definitely cancel x and dx at some way, and we know the integral of secant square of u, tangent of u, and we can substitute the values, the new limits. Okay, that's the same idea. 2x plus 1, and you know how to deal with this. I will skip this one. Okay, what about this one? This one we actually touching the fundamental theorem of calculus, part 1. That means now what we have a function that is defined as an integral, and we have to find the derivative of this. Okay? That's mean hopefully we remember how nice and smooth this question is if we know the concept. That means function g of x is defined as an integral from 1 to 1 over x, sine of t over t dt. And we asking you to find the derivative. Okay, that means we remember. Okay, let me ask you this way. Do you know what is the answer? Which function is, which option is the good option? No, okay, that means probably you can eliminate some of them. Okay, but let's see. That we remember, in order to differentiate an integral, they are like they are like opposite. They cancel like each other. That means derivative of this expression is just the same function, sine of t over t, but instead of t, we have to substitute the upper limit. Sine of 1 over x over 1 over x. We do have the constant number on the bottom, that's good. We don't have to switch the limits. But since the upper limit is just more complex than just x, we have to follow the chain rule. and we have to multiply by the derivative of the upper limit. That means the same function, sine of t over t, instead of t, 1 over x, that we can see this is not good option because it's missing the derivative of 1 over x. That means sine of 1 over x over 1 over x, and derivative of 1 over x is negative 1 over x squared. Okay, and well, we have to simplify. How can we do this? I can write sine over x, dividing by 1 over x is multiplying by x over 1, and negative 1 over x squared, which I can cancel out this, and I will end up again with sine of 1 over x and still 1x in the denominator and negative sign. This is the answer. Okay? But we can see the point is just to copy the same function. Do not do anything with the integrand. Take the same function and just multiply by the derivative of the upper limit.
Hey, sorry, I'm back.
Okay, this one is the same thing. Do you think you can tell me the answer? We have to differentiate the function f of x, which is defined as an integral from 5 to sine of x, and the function is square root of 10 plus t squared dt. The last, Josh is asking, the last question is just the derivative. 1 over x is x to the negative 1. The derivative is negative 1. Yeah, it's coming from the derivative, Josh. Okay? Okay, that means now we do have the answer. Hang on, somebody said, Zach said B. Yes, we can see. Copy the same function, instead of t, the upper limit, and times the derivative of the upper limit. Yeah, almost nothing. Oh, my box is not nice. Nothing to do. If we know the concept, that just done. Really good. Okay, that's me nice and easy points. Okay, now what we have? We have to evaluate the Riemann sum for the following function with 4 sub-intervals and using the right-hand endpoints as a sample points. Okay, that's me. Let's do it. We know how to draw a function for x minus x squared. I think we did similar today. It's just the parabola with 0 and 4 zeros, the x-intercept, and open down. And from 0, a little bit more, from 0 to 8, that means that's 4, that's 8. Right? I have to divide this sub-interval by 4. That means 2, 4, 6, and 8. Okay. And using the right endpoints, I will build my rectangle. That's the right endpoint. That's the right endpoint. 6 is the right endpoint. And 8 is the right endpoint. Will give me the height. Okay, that we can definitely see that the final answer will be negative because more areas, the blue areas, are below the x-axis. And that's the definition of the integral, and the Riemann sum is the approximation of the integral. Okay, that's mean right endpoints, 4 of them, and we have to find the value of the function at 2 times delta x. And we remember delta x is just the entire interval dividing by number of rectangles, 2, and it is 2. Plus value at 4 times delta x, value at 6 times delta x, and value at 8 times delta x. delta x is 2. Okay, and actually I will not, because I will not compute this because it's a little bit of arithmetic. You have to substitute 2 to the formula of the function and get the value. Substitute 4, 6, and 8, and then add together, multiply by 2. Okay? I only know that the answer is negative. Easy to guess. That means I can leave this answer, this question for you. But that's the good settings. Riemann sum is just the rectangles in this case. Okay, another Riemann sum. I can leave it. Oh, evaluate this. Which this question, what this question is doing, this question is testing if you remember a definition of a definite integral. Okay, that we have to definitely know. I can maybe rewrite this limit of the sigma from 1 to n, f of x sub I delta x means a definite integral from a to b of the function n dx. Right. We also have to know how the sample points are defined, a plus I times delta x. And delta x is just the entire interval b minus a over n. Okay, that means that's all of the formulas that we have to know, and let's see. That we do have a limit of the sigma. This is an integral. And now what I see pi over 4n, which probably will be my delta x. Let me rewrite this. Hold on. Maybe I can still rewrite. Okay, I didn't. Limit as n goes to the infinity, sine at pi, and this one is I pi over 4n, and times pi over 4n. Because what I did, I took this quantity, which looks like a delta x, and I rewrite like that, because we can see the formula. The formula is showing me the length of the entire interval from a to b, dividing by n. That means I just lift that 4 up. That means the length of the entire interval is pi over 4 that I'm integrating. But now I have to figure out is from 0 to pi over 4 or maybe from different value. Now let's see, because A is telling me the beginning of the interval. Limit of the sum is the integration. My function looks like sine, and we can see, can you see, this is my x sub I. X sub I, x sub I. And x sub I is defined as a plus I times delta x. A, that means what is the A value? Can you see? Like I'm just trying to match. A plus I times delta x. A is simply pi. Really good. As you can see, I did figure out based on the formulas. That means this is sine of x. We're not writing x sub I for the integration, integral symbol. That means this is f of x. That means that's my x. For the definition, it's x sub I. And we can see pi plus I times delta x. And this is delta x, which I will just write dx. But one more time, based on delta x, I have to figure out the upper limit. Because what I know that the length is pi over 4. That means since I'm starting from pi, what value shall I put on the top? Because we're starting from the pi, and we can just go pi over 4 units, which will be 5 pi over 4. Okay? Because this number, again, this number, pi over 4, it's telling me the entire length. Let's come back for a moment. Can you see that 8? I didn't write the difference, but this will be 8 over 0. Yes, that, I mean 8 minus, not over 0, 8 minus 0. That's the entire length. 8 minus 0. B minus A. And this is 8. That means this is the length of the entire interval, pi over 4. That means when I'm starting at pi, I can only go pi over 4, which will be 5 pi over 4. Okay, and I will leave this one for you. You can integrate sign and get the values from the unit circle. But that's important, the matching. And I believe I have one more. Let's continue nicely. See, this one is even easier. Limit of the sigma, it's an integration. This looks like xi. 5x to the power of 4 minus x. And this looks like delta x, which I will put dx. But delta x is telling me what is the entire length. I mean the length of the entire interval, which is 1. Can you see we really dividing n by 1. That means if the length of the interval is 1, I can possibly say from 0 to 1, or maybe from 1 to 2, or maybe from, I don't know, from 3 to 4. Okay? That means how can I figure out what is my A value? Do you think you can tell me what is the A value? Can you see this x sub I? Is, yes, the x sub I is just 1 over, I mean I times delta x. I can come back. I times delta x. That means I only have this part. I don't have any expanded form, which I'm assuming that A is 0. Because x sub I is I times delta x. This is definitely delta x, which will become dx. But since I have 0 plus I times 1 over n, we can nicely see that's x sub I and that's x sub I. That means A is simply 0, from 0 to 1. And you can also integrate this. The point is to rewrite nicely. Okay, I know it's nice review. But let me just come back. You have to know this definition and the additional formulas, x sub I and delta x. And as soon as you know this, it's so easy to match and rewrite limit of the sigma as an integral. Okay. Okay, that's me now. I think that was the last question from chapter 4. And let's move really quickly through the material from exam 1 and 2. That means this is the antiderivatives, which was the introduction to integrals, but we still didn't use a symbol. Okay, having the acceleration, okay, let me read actually. A particle moves in a straight line and has the acceleration given by sine of t minus 2t. We have to find the position function with the given condition. V at 0 is 2, S at 0 is 3. That means having an acceleration, we have to recover velocity and the position function. Velocity is simply the integral or the antiderivative. Antiderivative for sine of t is negative cosine of t. For 2t is t squared, plus the constant of integration. And if I substitute 0, I have negative cosine at 0 minus 0 squared plus c, and this is 2. Yes, I'm just using this. That means let's solve it. Negative 1 minus 0 plus the constant c equals to 2. That means constant c equals to 3. And that we can see because the common mistake is to repeat the same number. Okay, let's copy a function. Negative cosine of t minus t squared plus 3. Let's anti-differentiate one more time and get the possession function. Integral or antiderivative of negative cosine of t is negative sine of t minus t cubed over 3 plus 3t plus another constant. Okay? And then when I substitute instead of t0, the value is 3. That means 0, 0, 0. Actually, d is 3. Which answer will be correct? I believe this one. Because then I can substitute instead of d, 3. But instead of c, the first constant is actually also 3, not 2. That's the mean option. Okay, do not always compute the constant. Okay, let's see what else I have for you. Okay, that means that's this. I think this was also chapter 3. Already chapter 3, but that's fine. It's still integration. Okay, now chapter 3, 2, and 1. Funny, right? I'm going backwards. Let's see. Oh, okay, that's why I'm going backwards, but I start from chapter 3. That means chapter 3 was about the critical points. Okay, let's see what else. I can solve it for you. Intervals of increase or decrease, absolute maximum and minimum value, mean value theorem, vertical and horizontal asymptotes, linear approximation, implicit differentiation. That's what's the rate of change, okay? The rate of change question. That's also rate of change. And just the derivative, which actually I believe we jump to chapter 2. Derivative, because this is the chain rule. Derivative, chain rule. Okay. Intervals of concavity. And this is the question asking for inflection points, which is connecting to the second derivative. Derivative, because asking for the slope of the tangent line means the derivative. Slope of the tangent. Derivative, the quotient rule. Checking if the function is differentiable. I think this should be 5. Right? Just the limit. You remember that? Chapter 1 actually. Limit. Most likely you will see the limit, which with direct substitution you will get 0 over 0. But please remember, do not pick the answer 0 right away. You really have to eliminate 0 from the denominator and then eventually. But most likely you will have a finite number, or maybe the limit is completely undefined. But we know what we have to do. We have to find the way to simplify, to get rid of the 0 from the denominator, and then use the direct substitution. Absolute value limit, another absolute value, just the limit of the polynomials, continuity, another continuity. Oh, why this is solved? That's funny. I didn't, oh, okay. And then I know what it is. This is the optimization. Largest area, maximize, and maximize largest possible volume. Okay, okay, now, because I just went through all of these problems to show you, because maybe I will not solve all of them, okay, but I will pick some of the important ones. But again, you can't miss the question, right? You have to solve all of them, which you will see the solution because I will write down for you. Okay, and I see Josh is writing, can we do the rate of change problem? Of course, we can do it. And if you saw a question that you really like me to solve it, I will solve it. And I will, of course, I will also pick some of them. Okay, that's what we will do. What was the first question? That was the first question. Okay, let's No specific problem. Okay, I will try. Yeah, I can pick one that I have this. Okay, that means let's maybe solve this one because the function is not helpful and not nice. That means let's try to find the critical numbers of this function. Okay, that's when we will do this one. And then I will pick a few more questions, including the rate of change. Okay, first of all, what I see x to the power of 1/3. That means this is cube root. Cube root can take any numbers. That means I'm not worried for this. I'm thinking about the domain. But x to the negative 2/3 means that x is in the denominator. That means 0 is not in the domain. That means 0 will be not a critical number. Okay, for the critical numbers, I need the derivative. 1/3 x to the negative 2/3, positive 2/3, x to the negative 5/3. Perfect. Let's factor out 1/3 x 2. And now I can also factor out x to the power of lower number. Lower number is negative 5/3. This will be just 2. And this will be x to the power of number, and I believe this is 1, because if I distribute back x to the power of 5/3 times x to the power of 1, if I add the exponents, I'm supposed to get negative 2/3, and I'm getting negative 2/3, because negative 5/3 plus 1, it's negative 2/3. Excellent. Let's rewrite. 3 cube root of x to the power of 5 in the denominator because it's negative, and actually x plus 2 I can place on the top. That's what we need. That means now critical numbers are the zeros from the top, x plus 2 equals to 0, and the zeros from the denominator. Cube root of x to the power of 5 is 0 if x is 0. That means derivative is 0 or derivative is undefined. Okay, but we have to check against the domain, and we're checking this is not in the domain. Only negative 2 is a critical number. Critical number. Okay, always check against the domain and make sure that you can deal with this weird exponents. Okay, I will leave this one for you. I will leave this one. The mean value theorem, let me write for you. We have to find a number C that satisfies the conclusion of the mean value theorem. And this function is definitely continuous function and differentiable on the interval from 1 to 4. That means mean value theorem is telling me that f prime is the same like f of b minus f of a, b minus a. Okay? This kind of means graphically slope of the tangent. Okay. And this means slope of secant line. That means at some point from 1 to 4, function 1 over x will have tangent line which has the same slope that the secant lines. I can write that's 1 over x. The 1 value is here and 4 is here. That means when I connect this 2 dots, how can I do this? Okay, not bad. This will be slope of the secant between 1 and 4. I can actually put 1 and 4. F of 4 minus f of 1. 4 minus 1. Okay? And what I'm looking for the slope of the tangent somewhere here that will give me, parallel lines, the same slopes. That means let's just find this point. This will be point C. And that's the mean value here. Okay. We need on the left-hand side, we need the derivative. Derivative of 1 over x is negative 1 over x squared. And then the value of the function at 4 is 1 over 4 minus 1 over 3. 3/4 over 3. We can cancel out negatives and we have 1/4. Okay, that means this will be positive on -2, but -2 is actually not in the domain. That means x is 2, actually c is the number, c is 2. That means this is 2. Okay? But we can see that's the equation. Derivative, the same like the f of b minus f of a, b minus a. Okay? And I hope I didn't make the mistake 3, but it actually makes sense. 2, it's definitely between 1 and 4. Okay. I can leave this one. What about linear approximation? Do you remember linear approximation? Use the linear approximation to estimate square root of 79. That means we need linear approximation f of a, f prime at a, x minus a. But who can tell me, I know that it's a little bit late, as always, as we do the evening session, because a must be the nice number that will work well with my function. And of course, my function is square root of x. And what is the nicest number that I can, of course, compute the square root of it closest to the 79? That's mean, what do you think? What is the a value in this case? It's 81, of course. That's mean, let's find the linearization. Value of the function at 81, value of the derivative at 81, x minus 81. Okay. Function at 81 is square root of 81. Derivative of the square root of x is 1 over 2 square root of x, and we can substitute 81. Okay, that's mean my linearization is 9 plus 1 over 18 x minus 81. And I can still distribute, but what I will do, since I'm doing the approximation, I will say that 79 is the same like the value of the linearization at 79. I just wanted to use different color. And let's substitute 79. 18, 71. That means who can do 79? Who can do the math? 9, 18, 79. The difference between 79 and 81 is -2. That we have 2, 9 minus 1 over 18. That means what is the final answer? Can you do a little bit of fractions? 9 minus 1 over 18. Thank you, 1 over 9. I didn't cancel. Yes, 2 over 18, thank you. That means 9 minus 1 over 9, over 1/9. 1 over 9 is, am I right? That's the final answer, right? Oh yeah, not over 1 over 18, which actually I will get the wrong answer. Wow, because it's also, okay. But of course, what I want from you, I want you to know the linearization. Okay, let's see. We will leave this one. Oh, is that the related rates? Let's solve this one. If the radius of the circle is increasing with the rate 0.03 centimeters per second, what is the rate of change of the area when the radius is 20 centimeters? That's what we have. We do have a circle with the radius, and the radius is constantly increasing. dr dt, the rate of change of the radius with respect to time, it's, maybe I can write this way, 3 over 100 centimeters per second. That's the same number. And now we're asking the rate of change of the area with respect to time at the moment when radius is 20. But we remember radius is not really 20. We can just substitute at the end. But we just need the formula for the area, which is pi r squared, and we have to differentiate. dA dt, copy pi, derivative of r squared is 2r, dr dt. And then we have 2 pi. Now I can substitute 20. But my point was, do not substitute to the original equation, because then we'll get 0. Derivative of constant is 0. Okay, and this one is 3/100, which actually I can even keep. I can cancel out zeros, and 3 times 2 and times 2 is 12. 12 pi/100, which is 1.2 pi. Okay, and we need centimeters squared per second because it's the area. That's the square. Okay, that means you can definitely expect some related rates, not complicated, but something like this. Okay, let's see. Oh yeah, that's the ladder question, but I think in week 3 or 4 was the week 3, I think. I did solve this question, but I can leave it for you as a practice. This is just the derivative, not application, just to find the derivative. That we have cotangent square of 3x squared minus 1. That means I can rewrite this function as a cotangent of 3x squared minus 1, and everything is squared. That's when we do have a quantity squared. Derivative of the quantity squared is 2 times this quantity. Cotangent 3x squared minus 1 times, follow the chain rule, derivative of cotangent. Derivative of cotangent is, I would like to ask you, but I can answer, negative cosecant square of the same angle. Okay, and times derivative of that angle, 6x. And I believe that's the final answer. We can move it a little bit, we can clean it nicely, but we can nicely see the chain rule applied twice. 2 times the quantity, times derivative of cotangent, times derivative of the most inner function. Okay, what else? That's another chain rule. I can leave it for you. Okay, concavity, maybe we can do it. But again, every single question is important. I know that I'm repeating this. Even if I skip them, you will see I will post the solution for all of them. Okay, concavity. We do have a function, 2 plus 6x squared minus x to the power of 4. And we have to find wherever the function is concave up and wherever is concave down. Can you tell me, I hope you're not sleeping, which derivative we need to check concavity? The first one or the second one? The second one, thank you. That means you're not sleeping, good. Okay, that means let's find the first derivative will be 12x minus 4x cubed. And the second, that's second derivative, 12 minus 12x squared. Or maybe you can check my, yeah. Okay, that means now the second derivative is 0. We have to find the potential zeros. I can factor out 12. And I can factor out the quadratic expression. That means x is 1 or x is negative 1. Now I have to test negative 1 and 1, and we're testing a second derivative. If x is 2, the value will be actually negative. If x is 0, positive, and if x is negative 2, again negative. That means Function is concave down, concave up, concave down. And we have the answer. Concave up is between -1 and 1, and concave down outside that interval. Yeah, good question. Nice and easy question, but testing, important concept. Okay. How many inflection points? We can skip this one. Slope, you probably know the derivative. Maybe one of the limit, maybe the limit with absolute value, and then the trigonometric one. But again, if you're gonna try to solve the problems that I skipped, I mean, you will see the solution, but you can also still tomorrow ask the question on the discussion board. Okay, evaluate the limit as x goes to -2 of x squared minus 4 over x times x minus 2. That's we can see when I put 2, I will get 0 over 0. That means if I'm getting 0 over 0, most likely the answer is not 0. I have to just find the common factor, cancel out, and get the finite number. That means let's rewrite this. X squared minus 4 could be rewrite like that. And then absolute value of x minus 2, I can also rewrite. I mean, I have to rewrite without the absolute value. But we remember, if the quantity is positive, I can ignore the absolute value. But if the quantity is negative, I can't just write like that. I can copy this quantity, but I have to put extra negative. That means if x is 2 from the left-hand side, this means 1.9 or 1.999. 1.9 minus 2 is giving me negative number. That means this quantity is negative. What I have to do? I have to put extra negative. Let me move that x behind. Okay, that means we have to make it, because this quantity is negative. I'm making positive by adding this negative like this. Okay, now nothing is with absolute value. I can simplify my expression and I have my final answer. 2 plus 2, -2. 4 over 2, the final answer is -2. Okay, we can see how nice we can get the answer. But we have to do this definition of the derivative. Definition of the absolute value. Too many derivatives. Okay, and one thing, that's the same. Okay, let's solve this question, okay, because it's quite crucial. Contains two main concepts. That means what we have. Find the value of the constant c such that the function f is continuous everywhere. That we can see that the function, this is quadratic function, trigonometric, that means they are both continuous function. The only problem x equals to 1. That means in order for the function to be continuous, the limit from the left-hand side, and I will copy the function on the left, must be the same like the limit from the right-hand side. Sine of x minus 1, and I can rewrite x minus 1, x plus 1. Okay. That means who can tell me what is the limit on the left-hand side at 1? Can we simply substitute 1? 1 squared minus 1/4 times 1. I think it's 3/4. No problem at all. Just substituting 1. But what about this one? If I substitute 1, I have sine at 0 over 0. But do you remember this limit? Who remembers this limit from chapter 1? Sine of a over a as a goes to 0. What was this limit equal to? I changed a. I changed x for a. Okay, do you remember this limit? Now I know that you do sine of x over x as x goes to 0. Oh, no. The limit is 1. Okay, that we can see. This could be any value, but sine of 0 over 0. And let's see what we have. If x is 1, this is 0. 1 minus 1. But I see the same quantity in the denominator. You probably remember my section something, I think from week 2. I was like hugging this. Sine of 0 over 0. This is 1 because it's identical 0. That means my limit is c over 2, 1 plus 1. And now I can solve this equation for c. No problem at all. Okay, 6 over 4 cross multiplying 3/2. That means 3/2 will give me the value that the limits are equal to. If the limits are equal to, we have continuity. We also have the same value. Okay, that means, oh, hang on. Am I right? Because, no, okay, let's actually do, I just don't wanna confuse you. Because also the limit must be the same like the value. Okay, that means the limit on the right hand side is c over 2, and the limit on the left hand side is 3/4, and we can compute the c value. But also the exact value will be 3 over 4, which is the same thing if we substitute instead of c. I just don't like 1 on this part of the function. But that's it. Let's focus on the limits. I don't want to confuse you with these symbols. Okay, that means that's what we have to do, but please note this limit. Okay, that's extremely important limit. Okay, that's what I will do. As I mentioned multiple times, all of these questions here are extremely important. Okay, I did went through, like I did cover really precisely chapter 4 and 5. Okay, and maybe a little bit briefly chapter 1, 2, and 3, because that's the old material. Okay? That means if you will be confident with chapter 4 and 5, that's almost 50% of the test. And the rest of the stuff are from chapter 1, 2, and 3. But do not miss any question on this presentation. Check all of the solutions and practice. Please practice a lot your sample tests. Okay, and I'm sure you will be good. You can still post a question on the discussion board. The final week is always a little bit chaotic and we have lots of things to do, but I will try to answer your questions. Okay, and of course, check these slides. Okay, that means I will finish the session. Thank you, and I will still watch the discussion board for your questions. Okay, that means good luck with your final, good luck with your final review, first of all, okay? And please check these slides, okay? I will put them right away after the session. Okay, thank you.